Hi guys, this is a bit of an unusual video. I've been going through some of the Olympiad maths questions late at night, and yeah, I've always enjoyed challenging myself to see how I can solve these questions. And this one I came across a solution which was given by this person, and I'll put a link in my video so that you can have a look at what she's done. But I think I have a solution which I think will be easier to follow for some of you younger grade students. And also just to show you that these Maths Olympiad questions, often you don't need to be very proficient in math. Sometimes the solution is just there, just below the surface, and you just need to kind of be logical and also follow some of the rules that you've been taught. So I just want to show you how I would go about solving this question. So I'm going to make some space here, and I'm going to also post a link to this person's video so you can see how they do it. I just want to show you how I would do it. And as I said, no, I don't want to make it complicated maths. I really want to try and keep this as simple as possible and show you how the rules in problem solving, if you can follow them, they'll be quite make some of these questions easier than they seem. So the first thing is, this is a trigonometry question with the signs, but it's also an exponent question. So one of the rules that we always teach when we're dealing with exponents and exponential equations is get to prime factors. So what I mean by that is 81 we can actually turn into 3 to the 4. Okay. Sine squared x. So I'm not doing anything other than just following the rules. So even if I haven't seen the solution in my head instantly, this would help. And then the 30, I could do 3 times 10. And then I have a 3, and this becomes in 4 sine squared x, so just usual exponential laws. But when I look at this 3 to the 10, that doesn't help me because I can't really divide by 10 on both sides. So what I want to do is I'm still going to take that 3 out because look, we've got a 3 here and 3 here. So one of the tricks is to say, well, if I take a 3 out, instead of taking it out as a factor, let me just take 3 away from 30. And what am I left with? I'll be left with 27, which just so happens to be 3 cubed. And so some of the Olympiad brains out there are already going, okay, well, I've got the solution. And for those of you who can already see now, once you see that trick, it's pretty simple. With others of you, especially those grade 10, 11 and 12 and matric students, this now is quite instructive as to how to solve these trig equations. So I'm going to call this 3 to the 1, and then plus this, and then 3 to the 3. All right, so now what I've got is I'm going to sort of highlight what I'm immediately should be able to be obvious to most of you, is that if I look at both sides, they're pretty much the same thing. I've got a 3 to the something plus a 3 to the something is 3 to the something plus 3 to something. So essentially the 3's go away, and I could say that 4 sine squared x is equal to 1. And we could also write this as 3 to the 3 plus 3 to the 1. So I could do the 4 cos squared x equals as well, but I'm just going to stick to the 4 sine squared x. I'm just going to solve that one. And so I could then say that, so I'm going to highlight in green. And what I'm going to do is I'm going to do it in degrees first, so as not to confuse things. And then I'm going to do it in radians afterwards, because this other lady did it in radians, but I think most of my students, certainly, we start off in degrees, so it makes it easier. And then we'll just convert to radians at the end. All right, so we've got 4 sine squared x equals 1, or, if the 1 and the 3 were switched, then 4 sine squared x would equal 3. Okay, so then do using that one. Okay, and then I just divide 3 by 4 on both sides. And divide 2 by 4 there. Okay, and so well, I square root both sides. Well, we get a half, but also we get negative a half, because negative a half times negative a half would also give you a quarter. And by the same token, this would also then be plus or minus root 3/4. Okay, so I've pretty much done it now. And then what I can do is I can get my reference angle right now. It can be plus or minus. So if I'm looking at my quadrants, you'll excuse me, I'm going to do the quadrants in here. I'm going to use this white thing here. You know, class diagram. I'm actually not even going to bother with that because we know that. Okay, I'll just put the CAST just because that's what you used to. But of course, sine can be positive or negative. So it's any of these quadrants. All right, so let's just deal with that one first. So I'll just say we're doing it with a sine to the -1/2, the reference angle, and that is 30 degrees. So this could be 30 degrees here. And of course, going around here, this would also be 30 degrees. This would also be, and these all can be options. So now normally I would say 30 degrees plus K360, but of course, I could just actually say plus K180. And the reason is because I'm going to do this in a pink, so you know I'm talking about that one. If I go to another 180 degrees, just gives me that one as well. Okay, so it also gives me this. So the positive and this negative one over here, the K180. So rather than do all four, I'm just going to kill two birds with one stone there. And then this quadrant here is the 180 minus 30. So that's the 50-degree quadrant. And again, it's going to repeat every, so the reference angle was 30 degrees. And then so my answers are x equals 30 degrees plus K260 plus K180 and 150 degrees plus K180. And now when I want to convert to radians, well, let me do the other one first. I'm going to do it. Kind of my big head's in the way of this one. Okay, I'm just gonna make some more space here, so I'm ready. Don't decide too well here. But I'm gonna do the plus or minus root 3/4. Sorry, that's actually root 3/2 because I square root the 4, don't I? So that's a 2. And root 3/2, that's another special angle, isn't it? That comes from this angle here. This is 2 here. And so the 1 and this will be 3, wouldn't it? And so we got a sine, so it's theta, it's opposite over hypotenuse. So theta is actually there. So that's 30 and that's 60, isn't it? Okay, so it's a 60-degree angle is the other one. And so the other option is x equals 60 degrees plus K180. Exactly the way I did it. And then 180 minus 60 is 120 degrees plus K180. Okay, now when you look at the other solution, you'll just see it's in radians. So when we convert to radians, we times by pi over 180, right? And that's simple because you can see that the degrees cancel, right? So 60 becomes pi over 3, right? So let's go on to do the 60, it will be pi over 3 plus k pi is 180 times by 180 over 1. You see the 180s cancel. And then the 120, that's going to be 120 over 180, which is 2 over 3 pi plus k pi. Okay, and then for the 30 degrees, 30 over 180 is pi over 6. So it was 1 over 6. So this in radians, I wanted to do it would be pi over 6 plus k pi, and this would be 5 pi over 6 plus k pi. Okay, so the last part of the video, I think, might have bored a lot of you, but hopefully the part that resonated with everyone was this bit here. Was being able to spot that you could turn this 30 into 3 and 27. Once you do that, you've solved it. So often it's just like being able to look at that one thing, to spot that gap, and then it makes it much more simple. So let me know what you think in the comments. Maybe you've got some better solutions. Maybe you prefer the other solution. Perhaps I've made a mistake. Yeah. All the best for those of you who are preparing for your Olympiad. But just remember, just follow those rules. Sometimes you can't see the answer, but if you just follow those steps, wishful thinking as well can sometimes get you to the solution. Because you know, you may think, look at it and go, I've got the answer, and then you get a solution, which may be the wrong solution. But then when you realize that's the wrong solution, it can bring you along to, you know, what did you get wrong? And then eventually you can get to the right solution. So yeah, that's problem solving. You've got to get your hands dirty. Yeah, all the best. And sorry for talking so softly, but I am, my family is sleeping. So yeah, while I just carry on looking at maths videos on YouTube, which if you're doing the same thing, that's awesome.